everybody, and welcome back to Right Now Math with Mrs. Schmidt. Today, we are going to be talking about representing equations in two variables with tables, graphs, and situations. So, whoa, that's a whole lot. We're going to relate equations, tables, graphs, and situations. How is that even possible? Well, I just want to remind you really quick before we jump into equations that you've done this before. Think back to fractions, percents, decimals, and hundreds charts. Here is a great example of how these are four different ways that you can represent the same content. That is what we are going to learn how to do with equations, tables, graphs, and situations. So let's jump into it. So we're actually going to start today by looking at an example of how that's even possible. Let's jump into this. This is a chart right here, and in the chart you're going to see a graph, you're going to see an XY table, you will see an equation, and right down here it says verbal description. You can think of that as a situation or a story. All of this information in here is the same exact content. So I'm going to start down here with the verbal description. Let me read it to you. An athlete burns 200 calories weightlifting. Then they burn 10 calories for every minute X on the elliptical. They burned Y total calories. Based off of this verbal description or situation or story, whatever you'd like to call it, we were able to write an equation that described that story. So you could say Y equals 200 calories weightlifting plus 10 times however many minutes they were on the elliptical. And again, Y represented our total calories. So we've practiced that before. We've practiced taking word phrases and situations and translating them into equations. We have also practiced recognizing when we had ordered pairs, if they were solutions to our equation. For example, as we know, every ordered pair is made up of an X and Y coordinate. If an ordered pair is a solution, then when you substitute it in to your equation should become balanced. Let's try it out really quick to refresh our memories. So if my equation is Y equals 200 plus 10X, and I wanted to test this ordered pair, so it would be 10, 300. Remember, the ordered pair is always X, then Y coordinates. So we're going to substitute those values in. Instead of Y, I'm going to write 300 equals 200 plus 10 times, what's X? 10. This side's already simplified. 300 equals 200 plus 10 times 10 is 100. And 300 equals 200 plus 100 is 300. So because our equation is balanced, we would say, yes, this ordered pair is a solution to our equation. But that's where we've gone in the past. In the past, we would be given ordered pairs and asked to determine if it's a solution. But now we are going to be developing the ordered pairs. And the way that we're going to figure out these ordered pairs is by choosing values for X. So we already have an equation, and up here you can see where Mrs. Schmidt wrote that equation. 200 plus 10X equals Y. The same written up here equals Y. So if you are not given values for X, you are able to choose values for X. So I just chose 10, 20, and 30. And you can see how right in the center, we're substituting to figure out what would Y be. So when you substitute 10 in, Y has to be 300. So a solution would be when X is 10, Y is 300. When X is 20, substitute it in, you're going to get 400. So your solution or your ordered pair is when X is 20, Y is 400. Well, what about if X is 30? Substitute it in. Solve using order of operations, you get 500. So you know that when x is 30, y has to be 500. So instead of being given an ordered pair and testing if it is a solution, we are developing different solutions by choosing values for our x, substituting it in, and then creating our ordered pair. Very cool. So now that we have several ordered pairs, we can actually graph our information. So over here, you're going to see the graph of this information. 10, 300 is graphed. We have 20, 400, and 30, 500. So let's see what we've done. We had a verbal description or a situation. We were able to write an equation for it. Then, using this equation, we chose, or you will be given, values for x. Knowing different values for x, we substituted them into the equation to figure out if x equals this, what must y equal? That creates an ordered pair, which you can graph. Wow. There's some things to remember when you're doing these. So I wanted to kind of go through each of these. So we're going to start up here. It says if you connect the points, that means that any point on the line is a possible solution. So as you can see here, our points that we graphed, we did connect that line. So be aware of the context of your story and if it would make sense. So this is the story of this graph is that there was an athlete who was burning calories. So if there is a line connecting the space in between your points, that means any part of that line is a solution in something that could actually happen in the situation. So you have to ask yourself, is it possible for that athlete to be working out a portion of a minute and burn, portions of calories? Yes, it is, because the athlete doesn't just work out for 10 minutes, then teleport to 20 minutes, then teleport to 30 minutes. They're going to continue working out 10, 11, 12, 11 and a half, 12 and a half. They're going to be continuing to work out. So having that line is going to demonstrate to your reader that any point on that line is a solution. I could even come right here, and this point on the line, I could create an ordered pair from this point that when substituted in would make a solution for that equation because it falls on the line. All right, the next thing I want to talk about is if you are not given an x value, you get to choose your x values. So in this situation, the example was provided for you. There was 10, 20, 30. However, if there is nothing in the column, you get to choose your x values. And my suggestion to you is make your life easy. Choose values that are easy to work with, that will get you the data that you need in order to graph. You should use at least 3 values for x to create your ordered pairs, because just having 2 ordered pairs is not going to be, you want to at least have 3, because if you make a mistake, you'll be able to see that with the trend of your line. Also, way back over here again, when writing your equation, you need an independent and a dependent variable. So because we are going to have an x and a y ordered pair, you need to have an independent variable that will create the value of the dependent variable. So you need both of those things. Okay, how do I even start? Well, what you're going to do is you're going to look at these questions and you're going to say, what was I given? So for example, and this was kind of like the first one, we are starting with our story. We're starting with our situation. And you're going to notice what you were given, and then you're going to pick it apart and you're going to solve each of the additional pieces. So a cheese pizza costs $5. Every additional topping costs $1.50 extra. Let x be the number of toppings and y be the total cost. So I'm going to take the situation and write an equation from it. My total cost is going to be, well, I know the very least. If I just got a cheese pizza, it's going to be $5. Plus, How much is each additional topping? $1.50 for every additional topping. So I'm going to put an X. All right, so I've written my equation from my situation. Now I'm going to come up to my chart and I'm going to use this equation to develop my ordered pairs. So I'm just going to say, well, what would happen if I have no toppings, no additional toppings, and one topping and two toppings? You could even say what would happen if I had three toppings. So we are going to take this equation. So you can see it's written backwards here, but that's okay. So it's just 5 plus 1.5x equals y. And we're going to substitute these values in for x. 5 plus 1.5 times 0 equals, well, think about it. 1.5 times 0 is just 0. So if you have no additional toppings, 5 plus 0, when you have no additional toppings, that means the price of your pizza will be $5. And I got that from just evaluating that sentence. So let's try 1. We have a $5 pizza plus $1.50 for every topping. I only want 1. So when you're going to have one additional topping, you would have $5 plus 1.5 times 1 is 1, $6.50. So when you have one additional topping, your pizza will cost $6.50. Now, if you notice, we're creating ordered pairs. You could continue on through that. I'll just do the next one. So we have $5 pizza plus 1.5 times 2. So I know that it's $5 plus 1.5 times 2 is 3. So if I have 2 extra toppings, the price of my pizza is going to be $8. So what have we done so far? We took our situation, we wrote an equation. We picked values for our x because they were not given to us, so we were able to pick them. We substituted them in to our equation to create ordered pairs. Now what can you do with ordered pairs? You can graph them. So in order to do that, you're going to need to label your x and y axis. So I'm going to take a second right now and do that. All right, so now that I've labeled this, let's see what I did. I labeled my x-axis toppings because that's what it has been standing for my entire time with my situation and my story and my x value over here. My y value is my total money, my total cost. So if you are having 0 extra toppings, your pizza will cost $5. 0 extra toppings, your pizza will cost $5. 1 extra topping, your pizza will cost $6.50. 2 extra toppings, your pizza will cost $8. And you could go on further down the x-axis and continue graphing if you wanted. Now, I want to ask you, would it make sense to connect these dots? Well, remember, every time you connect the dots, that means that every single point on that line is a solution that could happen in the context of your story. So you have to ask yourself, does it make sense to have portions of these units? Are you going to have a portion of an additional topping? No, the pizza place is not going to do it. They're like, you want 1 topping, 2 toppings, or 3 toppings? Are you going to So because that does not make sense, we are not going to connect these dots. All right, so we've talked about what happens if you start with your verbal description or your story. We make the equation, do the graph, then graph it. But what happens if you're given the graph and nothing else? Well, you're basically going to go in reverse order. You're just going to pick apart what do you know and go slowly backwards and picking one piece out at a time. So if I look here, what do I know? I have a graph and I have some units. So I'm going to look here. What do I know? I know that when x is 1, y is 10. And I can tell that by that ordered pair right there. So when x is 1, y is 10. All right, let's get some more information. When x is 2, y is 20. And I'm just filling in my chart. When x is 3, y is 30. All right. Looking at this, I need to figure out what is the rule. This is my input number. When I put 1 in, what happens to turn it into 10? What is happening right here? Well, to me, there's two things that could happen. If I put 1 in and I get 10, I'm either adding 9 or I'm multiplying by 10. So I'm going to either add 9 or multiply by 10. So let's test these two rules with the other ordered pairs that we know are solutions. If I put 2 in, 2 plus 9 would be 11. Does that equal 20? No. Let's try times 10. 2 times 10. Does it equal 20? It does. Let's double check with 3. If I substitute 3 in, 3 plus 9, 10, 11, 12, that's 12, definitely not 30. But 3 times 10, would that work? Yes, it does. So I know that my rule is put x in and times it by 10. So I can write that as 10x. So down here, you could write 10x equals y, or you can write y equals 10x. Either is okay. So how did I do that? I looked at my graph. I pulled my ordered pairs out. And then I tried to figure out what's the rule. If I'm putting my x value in and getting my y value out, what is the rule that's happening to, create that? And then last but not least, you look at your equation and you get to come up with a story that suits this equation. I happened to come up with a situation previous to this. So the situation I came up with was it costs $10 for every ticket purchased to the baseball game. Let N be the number of tickets purchased and Y be the total cost. So $10 for every ticket is your total cost. So if you're buying 1 ticket, you're going to pay $10. If you're buying 2 tickets, you're paying $20. 3 tickets, $30. All right, our last example is, what if I'm given the equation first? Well, you kind of can start wherever you want. You can write a verbal description. You can come up here and say, okay, I know my rule is x plus 3. And you can just pick some values. I don't care what it is. It could be 1, 2, 3, 4, 5. Think about, you're going to have to eventually graph these, so it might just be easy to do 1, 2, 3, at least 3 numbers, more if you want or if the question calls for it. Substitute it in and create your ordered pairs. So 1 plus 3 is 4. So when x is 1, y is 4. We have 2 plus 3 equals 5. So when x is 2, y is 5. Substitute them in, then go over, label your graph, and plot. So you can really choose however you want. You can make the story first, whatever you would like. Okay, so what did we learn? We learned that we can represent the same situation with equations, tables, and graphs. We also talked about that a good strategy is to start with what you've been given and then pick the puzzle apart piece by piece. Another thing to remember is you should have an independent and a dependent variable. So 2 variables in every equation so that you can create those ordered pairs so that you can also graph. All right, ladies and gentlemen, good work. I hope this was helpful, and thanks for joining me on this episode of Right Now Math. Have a great day.